Alright, physics friends, we're going to do problem 3 in unit 11, which is actually chapter 16 in your book and notes. So, we're going to just get to it and try to crank it out pretty quickly and we can move about our day. And so here it is. These are the answers, by the way, in bold. A couple things to note. This, whoa, did it again. Oops, I did it again. So, these Q's have it in micro. The prefix micro is, it's an easy to turn it to coulombs because, well, there's a little, just said it should not be micro. But anyways, I had a little bit of a difficulty cutting and pasting those in here. But what are these really? This is 1.71 times 10 to the minus 6 regular coulombs, and that's Q1. And Q2 is 5.23 times 10 to the minus 6 coulombs. And this is negative 2.94 times 10 to the minus 6 regular coulombs. So you need to have those in regular coulombs, not micro. I just converted them for you pretty quickly. And you also need these in meters. So this is 0.0296, and this is meters. And this is 0.0184 meters. So that's the distance in here. I'll put it down here. 0.0184 meters, and this is 0.0296 meters. Okay, so what we need to do is we want to know part one is what is on Q1. So what is the force? It's hard to read, but it says it up here, Q1. That's it. That's what we want to find the first force on. So we want to know, use Coulomb's law. Let's do it here. F, I don't like that color there. F of 1 and 2, between 1 and 2, and we need to know the F of 1 and 3. What about 2 and 3? Yeah, we're going to need that for the later problems, but we don't need to know how they're kind of playing around, interacting with each other as of this moment, because we're finding what is the effect on Q1. So what is 2 doing to 1, and what is 3 doing to 1? So we need to fill into Coulomb's law, and I did not leave myself very much room. But the formula is K, that constant, times Q1 times Q2 all over R squared, distance squared, and this is, and we're going to go slide downhill here and give myself some more room. Whoop. And this is Q1, Q3 over R squared. Okay, this one, 8.99 times 10 to the 9th. We'll leave units off because we made all the units play nice. We turned these to coulombs, we turned those to meters. We're good. Times, and it's 1.71 times 10 to the negative 6 times, and it is 5.23 times 10 to the minus 6 all over 0.0296 meters. Squared. Oh, squared, yeah. And when we do this, I get 91.76 newtons. You might say, oh no, not on this one. But there we go. That's the F1 on 2. You got to find now F1 and 3. We'll do it in a different color. We'll do it in purplish. And it's 8.99 times 10 to the 9th. All over. Oh, we've got some more. Okay. And Q1 is 1.71 times 10 to the minus 6. This is bad, sorry. Times, this is 2.94 times 10 to the minus 6. You might be, oh, the negative sign. Well, you could put I would suggest not putting the negative sign on. We'll decide the direction when we get these numbers. But now we do need the distance. This distance is the sum total of this one plus this one. Okay, so between these two, it's this plus this. So this is 0.048 meters, and we got to square that. Okay, so that once again is this one plus this one, because how far is it from here to here? It's the sum total of those two, or 0.048 meters. When we get this, we get for that one 19.62 newtons. All right, now we have our two forces. That's all that's acting on them, and it's all in a line. So we need to be careful, though. Careful. So here is Q1. Okay, it is a positive. Q1. What is the force of Q2? It's this here, okay? Now, Q2 is positive. So what is Q2 doing to Q1? Is it pushing it to the left or pulling it to the right? And since they're both positives, like charges repel, so 2 is pushing 1 to the left. So that is a leftward force of 91.76 newtons. Now, what is 3 doing to 1? It is pulling it. Opposites attract. So 3 is pulling 1 to the left. How much? 19.62 newtons. So it's a tug of war match. Who is winning? The negatives here. You can make this a negative and add them, or you can just subtract this off. Anyways, your net result, the net force, when you do this, is a negative 72.1 newtons. And that is our first answer right there. Okay? All right, let's continue. Part 2. Okay? Let's containerize this. We're on this one now, right here. Okay? Part 2. We need, what is the force on 2? Well, we need, what is 1 and 2? And what is force 2 and 3? We already did the magnitude of 1 and 2. That's right here. It's right up here, 91.76, because the force that 2 exerts on 1 is the same in size, magnitude, as 1 on 2. So it's 91.76 newtons. Now, we do have to calculate this one because we've not done this one. K times Q2, Q3, and the distance squared. Okay? And this is 8.99 times 10 to the 9th times, I'm going to find my numbers here, 5.23 times 10 to the minus 6th times 2.94 times 10 to the minus 6 all over. But be careful, this is just that singular distance. It's just this one here, 0.0184 for me. So it's 0.0184 squared. And when we do this, I get 408.29 newtons. All right, so we have our two forces. So we need to look up here. We have a positive in the middle. Okay. We have positive, positive, negative. And this is the one we care about. Okay, let's get some. Okay, what is, this is 1, this is 2, and this is 3. What is 1 doing to 2? 1 is pushing 2 to the right. Oh, you switched signs, yes. On the first problem, 2 was pushing 1 to the left, so it was negative. But 1 is pushing 2 to the right, so it's a positive force. 1 on 2 is to the right. So I'm just going to draw a arrow here, and it is 91.76 newtons to the right. What is 3 doing to 2? Opposites attract, so it's pulling it. So this is pulling it at 408.29 newtons. All right. Now, when we add those two, because they're both in the same direction and they're both positive, we get 500.1 newtons. So it's a force to the right. All right, I'm going to squeeze in the last one here. Okay, so that got us this one. Check. We're now on 3. Okay, we need F 2 and 3, and we need F 1 and 3. We've already calculated those. Here's F 2 and 3. It is 408.29 newtons. And what is the magnitude of the 1 and 3? 1 and 3 is right here. Okay, 1 and 3, check, right there. 19.62 newtons. Magnitude, 19.62 newtons. Magnitude, we don't know the sign. Yes, force is a vector quantity, so I should have the correct sign on there, but we're putting the direction on here in a second. I find it easier to just do it at the end. Okay, so here we go. We have a positive, this is 2, a negative, this is 3. We can put circles, happy little circles around them. And here is positive here. So what is 2 doing to 3? It is pulling it this way. So that's 408.29 newtons. So that's a negative if you want to put the negative on there. And what is this one? What is 1 doing to 3? Opposite, so it's pulling it. They attract, so it's pulling it toward it. 19 or negative 19.62 newtons. So you add the 2 and we end up with a negative 427.9 newtons, and that's it. That was a lot. Rewatch the video if you have to. Hey, let's be honest, you guys are rewatching these anyways, right? Because they're so entertaining. And I'll see you on the next problem.